Hi everybody, welcome back. Today we're going to take a look at 10-4 ellipses. So first off, what is an ellipse? An ellipse is an oval type shape. Now we're going to get a little bit more in depth here with where an ellipse comes from and what is the actual definition behind it. But everything that you seem to be calling an oval usually is what we're going to describe as an ellipse. So here's our actual definition. An ellipse is the set of all points in a plane such that the sum of distances from two fixed points is constant. These two fixed points are called the foci of the ellipse. So here's my given ellipse. I have 2 points. This is F1, that's focus 1. This is F2, that's focus 2. An ellipse is the set of all points whose sum is a fixed constant. So if I take this distance plus this distance, anywhere on this ellipse, those two added together are always going to add to a certain constant. An ellipse has 2 axes of symmetry. The points at which it intersects these axes of symmetry are the endpoints of the major and minor axis of the ellipse. So if you look right here, the major axis is the axis that gives it the longest length. So this would be the major axis. This point and this point are the vertices or the endpoints of that major axis. The minor axis would be this way, and this point and this point would be the endpoints or the vertices of the minor axis. Every ellipse also has a center, which in this case is located directly at the origin, and that center is the location where everything starts. So when we graph an ellipse, we're going to start with the center, and we're going to go a certain distance to find the foci, a certain distance to find the axis, the major axis, and a certain distance to find the minor axis. Now, what are these distances? Well, once I locate the center, the distance from the center to the outside vertex on the major axis is a length of A. The distance from the center to the minor axis is a length of B, and the distance from the center to the foci is a length of C. Now, this distance C from the center to the foci can be found by completing the formula C squared equals A squared minus B squared. A and B, as you'll see in a minute, are pretty easy to find. So once you know A and B, C is the tough one to find. And again, A squared minus B squared is C squared. That will give us our foci points. So here's our standard equations for the ellipse. Let's start with the horizontal ellipse. This would be the direction of the major axis. So my ellipse would look something similar to this. This would be the horizontal version. This side over here, this would be your vertical ellipse, so it would be this way. The horizontal, the standard form is x squared over a squared plus y squared over b squared equals 1. Again, horizontal. The foci is located at C0, negative C0. Major axis has a length of 2a because you go a units to the right and a units to the left. The minor axis has a length of 2b. For a vertical ellipse, we'll see the y squared coming first. So it'll be y squared over a squared plus x squared over b squared equals 1. One thing to point out here, how to determine whether it's a horizontal or a vertical ellipse, A makes that decision. Whatever is bigger, that becomes A. The foci then switch. The foci are located at 0C, 0, negative C. The major axis is 2A, the minor axis is 2B, except of course major axis will be going vertically, whereas the minor axis will be going horizontally. So, first question, let's write an equation for this ellipse. Well, first thing I notice when I take a look at this ellipse is my center is at 0, 0, and this is a vertical ellipse. It's longer vertically than it is horizontally. So because it's longer vertically, this makes it y squared over a squared plus x squared over b squared equal to 1. Now I simply have to figure out what is a squared, what is b squared. Well, let's start with a. A is half of your major axis. So we already said major axis was this one here. So half of that would be from the center to that vertex. That's a length of 5. So that means A is 5 units. So over here, I need y squared over a squared. 5 squared gives me 25. X squared is now over b squared. B is half the length of the minor axis, so from the center to the vertex is this distance, which makes b equal to 3, and my formula x squared over b squared, or x squared over 9. And there's the equation for your ellipse. Let's try another example here. Listener standing in an elliptical room 150 feet wide and 320 feet long. When a speaker stands at one focus and whispers, the best place for the listener to stand is at the other focus. Write an equation to model this ellipse, assuming the major axis is horizontal and the center is at the origin. So, major axis horizontal. So let's put it this way. So if my major axis is horizontal, that means this distance from here to here is your major axis. This distance from here to here, minor axis. Now, they went ahead and said that the center is at the origin, and since my major axis is horizontal, this will be an x squared over a squared plus y squared over b squared equals 1 formula. Now, they tell me that one person stands at a focus. The best place to listen is at the second focus, this point right here. That's important for setting up this room, but not necessarily what I'm looking for here. All I'm looking for here is the actual equation to model this ellipse. So to figure this out, I have to figure out what A and B are. And remember, A is the length of the major axis, which is this distance here. Now I know there's 320 feet in length. 320 feet marks from end to end, which means halfway between there. Let me pull up my calculator. 320, I want half of that, will be 160. And when I plug that in my formula, I want 160 squared. 25600. So we'll have x squared over 25,600. Y squared over b squared, where b is the length, half the length of your minor axis, or this distance. I know my minor axis has, my ellipse has a width of 150 feet. So again, I want half of that number. So that's 75, and we want to square it. 5625. 5625. So the equation of my ellipse, x squared over 25,600 plus y squared over 5,625 equals 1. Alright, how far apart should the speaker and listener be in this room? Now, let's go back here. Let me see if I can copy this and bring this over. Okay, here's my picture from before. I want to know how far should speaker 1 be from speaker 2. The speakers are located at the foci, and if you remember the foci, the distance from the center to one of these foci was given as a length of c. C can be described as a squared minus b squared. Now, I've already done all the work for this. A squared I found earlier, and so did b squared. So let me bring my calculator up. So it looks like a squared is the 25,600, b squared was the 5,625. So we have 25,600 for a squared minus the b squared, which was 5,625. And I can find that difference by subtracting. Now, keep in mind this number here, this is c squared. So to find c, I actually need to square roots that given number. The square root of that number gives me 141.3. Now, let me slide this over. C, remember, is the distance from the center to a focus. If I want to know how far apart the speaker and the listener should be, it's C this direction, and it's also C this direction, which means the total distance between these is twice this amount, or 282.6. And that number there is the distance between our speakers. Alright, so let's put one of these all together here. Find the coordinates of the center and the foci and lengths of the major and minor axis of the ellipse with the equation x squared over 36 plus y squared over 9. And then I want to graph the ellipse. So, first thing I do, let's locate the center. This formula here tells me center's at 0, 0. That's what I was given before. Because this number is bigger and it's under the x, it tells me my ellipse has to be horizontal. Now keep in mind this number is a squared. So a is simply the square root of that number, or 6. A tells you how far from the center to go on the major axis. So that means I'm going to go 6 units to the right, and I'm going to go 6 units to the left. I'm also going to find b. B is given from this number. Keep in mind this is b squared, so b has to be 3. B is the distance you travel on the minor axis. So in this case it's 3 up and 3 down. So the length of my major axis is 6 plus 6, or 12. The length of my minor axis is 3 plus 3, or 6. My center, 0, 0. And I have one more thing to find, and that would be the foci. And the way I find the foci is I find C. Keep in mind C squared is A squared minus B squared. So C squared is 36 minus 9, or the square root of 27. So pulling up my calculator once again, let's find the square root of 27 as a decimal, and that would be about 5.2. So we'll say C is about 5.2. Now what that means is my foci are located 5.2 from the center. So I would go 5.2 this direction, about right there. So one of them is located at 5.2, 0, and the other one located in this direction, which is the points negative 5.2, 0. Last thing, let's connect this all together. I'm going to use my ellipse tool. Let's see how good I can get here. So we want it one on this side. Let's see how that looks if I drag it down here. No, not bad. So there's your ellipse. Center at 0, 0. Major axis length at 12, minor axis length of 6, and the green dots represent your foci, which are at 5.20 and negative 5.20. Okay, let's try one more. This last one, this is the hard ones. Much like the circles and parabolas that we've done before, this is called standard form. And if you have an equation that is in this form, you first have to complete the square before you can actually find your answer. So let's work our way through. Let's complete the square here. Let's see what I can come up with. So we'll start with my x's. So we'll go x squared minus 6x plus b divided by 2 gives me a negative 3 squared. I get 9. So I got x squared minus 6x plus 9 plus 4y squared. Now, when you complete the square, the leading coefficient, or the number in front of the square term, has to be 1. So what I'm going to do is I'm going to factor 4 out from this as I do this problem. So minus 16y, if I were to take a 4 out, this is now minus 4y. Complete the square, so 4 divided by 2 is 2, square gives me plus 4. From there I have it completed the square, equals my constant. I'm going to add that to the other side, so I got a plus 11 on this side, and when I complete the square I got to add back in what I put on this side, so I go plus 9, and I go plus, not 4, but keep in mind I took a 4 out from the beginning, so I actually went plus 16. Now the whole reason for completing the square, this will now factor into x minus 3 squared. This one 4 and y minus 2 squared. 11 plus 9 is 20, plus 16 gives me an answer of 36. The ellipse always has to be equal to 1, so I divide everything by 36, which means this is x minus 3 squared over 36 plus y minus 2 squared over 4 divided by 36 gives me a 9 equal to 1. And now we're ready to graph. Let me pull up my graph. Make this a little bit smaller so I have some room to work. Okay, a couple things I noticed first off. It looks a little bit different than the previous ones that I did. But keep in mind, this is simply a transformation, just like with circles. X minus 3 means we're going to shift 3 units to the right. Y minus 2 means you're going to shift 2 units up. So my center is actually located at 3, 2. So everything that I now do is going to go from that center point. So we'll start off with A. A is the square root of this number, which is 6. So it's 6 units to the right and 6 units to the left. B is the square root of this number, or 3 units up and 3 units down. And the last thing that I need to see, keep in mind C squared is A squared minus B squared. And I believe these are 2 numbers that we actually just did. 36 minus 9 is 27. Square root of 27, if you remember, was 5.2. So it's 5.2 units this way, 5.2 units this way, and I'm ready to draw my ellipse. So if we put everything together, there's your ellipse. And that is 10-4. Have a good night. We'll do some practice to this tomorrow, and we'll go from there.